So, from what I've been told as feedback from you guys, I've noticed that some people are having some trouble simplifying some of the derivatives of logarithms and exponential functions. So what I thought I would do is make a video going over some of the problems on page 40 and 41 of your packet so that you could see some of the simplifying that has to go on. I'm going to skip problems 1 and 2 because I thought those were pretty straightforward, and we're going to start with problems 3 and 4. I'm going to walk you through how to take the derivative and all of the steps that you would use to simplify. So for problem 3, if I wanted to take this derivative, I know that I would need to use product rule. Now, product rule says we copy the first problem, take the derivative of the second. Now, the derivative of e to the something is just e to the something times the derivative of the exponents part. Now, I'm not taking the derivative of the e part anymore. I'm just doing the derivative of the exponents, which would be 9x squared. Next, we put a plus sign, and we copy the second problem, which would be e to the 3x cubed times the derivative of the first part, which would be 4x. Now all I really have to do here is to simplify this problem. So in order to make it look a little bit nicer, I'm going to take the 9x squared and put it at the beginning. I'm also going to take the e to the 3x cubed and put it at the beginning, and leave the 2x squared plus 5 inside the parentheses. Then I'm going to take the 4x and put it at the beginning, and e to the 3x cubed. One of the things that I can do from this point to make it even simpler is I can factor out the e to the 3x cubed. So if I factor that out of both terms, and I'm also going to at the same time factor out an x, I'm going to have x e to the 3x cubed, and what's left over will be 9x times 2x squared plus 5 plus 4. I'm going to simplify what's inside of this parentheses. So I would distribute, and I would get 18x cubed plus 45x plus 4. And then I would just leave the x e to the 3x cubed on the outside, and I'm done. So one of the things that we can do algebraically to simplify a problem that we should probably always check for is to factor out a common factor. Now we're going to do let's do problem 4 next, because problem 4 is going to help us look at another algebraic process that we can use to simplify a problem. So problem 4 is also going to require product rule. In order to do that, I would copy the first factor, which is ln of 5x cubed. I'm always more comfortable putting the inside stuff inside of a parentheses, times the derivative of the second part, which is 4x cubed, plus copy the second factor, which would be x to the 4th plus 3, times the derivative of the first factor, which would be 1 over the stuff, 1 over 5x cubed, times the derivative of the stuff, which would be 15x squared. Now all I'm going to do is I'm going to simplify. So I'm going to put the 4x cubed first, just so it looks a little bit nicer, times ln of 5x cubed, plus, and now I'm going to simplify. So the 5 and the 15 reduce to 3. 2 of the x's cancel. There's just 1 left. So on the top of my fraction, I would have x to the 4th plus 3. And on the bottom, I would have x. Now from here, in order to make it look a little bit simpler, or in case I'm taking a multiple choice test and this does not match one of my answers, I could continue on by doing the algebraic process of making a common denominator. So, because this first fraction would technically right now have a denominator of 1, I need to multiply by x on the top and the bottom in order to make a common denominator. My new problem would be 4x to the 4th, because I have an extra x now, times ln of 5x cubed, plus x to the 4th. Oh, there should be a 3 here. Sorry, I forgot about that. 3x to the 4th plus 9. And then I'm done. All right, now I was also told that some of the quotient rule problems were a little bit tricky. So we're going to go ahead and we're going to look at number 11, which involves us having to use quotient rule. So to take the derivative using quotient rule, I'm just going to move my paper so you guys can actually see what I'm writing. To take the derivative using quotient rule, we would use low d high, high d low, and low squared goes down below. So I'm looking at problem 11. So the derivative would be low, which is log base 2 of x to the fifth. And again, I'm more comfortable putting that inside stuff inside of a parentheses. Woo! My paper just flew away. Log base 2x to the fifth times derivative of high, so 8x, minus high, which is 4x squared plus 1, d low. Now the derivative of a logarithm says put the stuff on the bottom times the natural log of the base, which also goes on the bottom, then times the derivative of the stuff, which would be 5x to the fourth. That's the chain rule part right there. And low squared, which would be log base 2 of x to the fifth squared, goes down below. Now it's just a matter of simplifying. So to make this look a little bit nicer, I'm going to copy the 8x to the beginning, write log base 2 of x to the fifth, minus, now this does reduce a little bit, so the x to the fourth and the x to the fifth reduce, which means I get the 5 is going to go on the top, the 4x squared plus 1 is going to go on the top, all over the natural log of 2, all over log base 2 x to the fifth squared. Now the algebraic process that we're going to do here to make this look a little bit simpler is to multiply by the denominator in order to eliminate the issue of having a complex fraction. So you'll notice we have a fraction within the numerator of a larger fraction. To make that go away, we're going to multiply by whatever that denominator is. Now that does get distributed to every term. So when I do that, I get 8x log base 2 of x to the fifth times the natural log of 2 minus, the natural logs cancel, that's kind of the whole point, 5 times 4x squared plus 1. And you could distribute that 5 if you wanted to. It's not going to really significantly change the answer. And then log base 2 x to the fifth squared times, and we need to multiply by that natural log of 2 on the bottom as well. Oop, let me move that up a little bit so you can see it. So we've looked at 3 ways to simplify a problem using algebraic processes. We've said you can look at factoring out a common factor, you can make a common denominator, or you could multiply by a denominator to make your problem look a little bit simpler. Now, let's look at a couple of the tangent line problems. A lot of students were saying, oh my gosh, this wasn't in the video, what are we doing here? Keep in mind that the process of finding a tangent line is never really going to change. We're always going to start by saying, okay, if we want the equation of a tangent line, we know we're going to need a point and we know we're going to need a slope. So the point they give us is 3 comma the natural log of 5 in number 13. And to figure out the slope of a tangent line, we know we need to take the derivative. So really, we're just practicing more derivative rules here. The derivative of natural log says put this stuff on the bottom. Since there's a negative, you would just put a negative 1 on the top. It's like having a coefficient of a negative 1 over x plus 2. And you normally do chain rule, but the derivative of x is just 1. So it doesn't really change the problem to multiply by 1. Now what I need to do next is I need to find that value at 3. So I'm going to take the number 3, because that was the given x value in the problem, and I'm going to plug it in for the x value. So 3 plus 2, which means we get negative 1 over 5. Now when I write this equation, I would have y plus the natural log of 5 equals negative 1/5 times x minus 3, We could, if we wanted to at this point, rearrange this to get it into slope-intercept form, which is what the answer key for the worksheet did. We don't have to. Like when I'm grading your test, that's good enough. I think that's it. Like that was the big 3 ideas that I think students really wanted to go over: product rule, quotient rule, and tangent line problems. So I will be available here at school on Monday for any extra questions that you might have, and I hope that this helps with some of the algebra stuff that was kind of going on that worksheet. I'll see you guys then.